Okay, let's dive right into this. Welcome to this explainer. Today, we're going to do something a little different. We are going to treat your Cambridge 9709 mathematics exam paper not just as a test, but as a film script. You are the director, and your absolute goal, build a blockbuster answer. Think about your favorite movie for a second. What makes it so great? It's not just some random collection of scenes, right? It's carefully constructed. Every single shot has a purpose. Every piece of dialogue drives the plot forward. Anything that doesn't serve the story, well, that ends up on the cutting room floor. And honestly, this is exactly how you need to approach the Probability and Statistics 1 module, specifically the notoriously tricky Permutations and Combinations section. We're going to teach you how to cut the filler, keep the auction, and direct a mathematical masterpiece that examiners literally can't help but give top marks to. We're taking an exclusive, insider look at the specific methodology, the critical analysis skills, and the exact procedural framework that principal examiners are actively hunting for. So grab your director's chair because we're about to break down your script. Here is our production schedule for today's session. Number 1, the 15% hook. 2, the command framework. 3, the rewrite. 4, the interactive workshop. And 5, the top mark system. Let's get to it. All right, section 1, the 15% hook. Now, every great blockbuster opens with a hook, right? A sequence that tells the audience exactly why the stakes are incredibly high. In our Cambridge mathematics journey, setting the stakes is all about understanding the weight of the material sitting right in front of you. You really need to know where your effort is going to yield the biggest return on investment. Here's the thing. Probability in Statistics 1, specifically permutations and combinations, accounts for approximately 15% of the total marks in Paper 2 of your Mathematics 9709 exam. Let that sink in for a second. 15%. That is a massive chunk of your final grade wrapped up in a single distinct conceptual framework. It's literally the difference between an A and a B or a B and a C. You cannot afford to just improvise this scene. You need a systematic, evidence-based reasoning approach to secure every single one of those marks. To really understand how to win those marks, we first need to look at how students typically lose them. I want you to meet Alex and Sam. Honestly, think of them as two directors who have completely misunderstood the assignment. Alex's approach? Well, Alex tries to show off by overloading the answer with raw mathematical facts. They're writing down every single formula for factorials, permutations, combinations, basically just hoping the examiner will pick out the right one. It's all exposition and zero plot development. There's absolutely no analysis of whether the objects are identical or distinct, or if the arrangement has restrictions. It's just a massive data dump. Sam's approach, on the other hand, is like an action director who just rushes straight to the explosive finale. Sam completely misses the command word requirements. No identifying the key elements, they just crunch some numbers in their head, slap down a final answer, and move on. No proper presentation, no defining if order actually matters, and no systematic processing. Both of these flawed scenes fail to score top marks because they completely lack connected conceptual understanding. The examiner is looking for a structured narrative, and neither Alex nor Sam is delivering it. Moving on to section 2, the command framework. So how do we actually fix this? Well, we need to look under the hood at the mathematical breakdown of what Cambridge examiners are actually targeting. They're looking at 3 distinct cognitive domains. First, knowledge and understanding. This is knowing the fundamental difference between a permutation, where order absolutely matters, like typing in a password, and a combination, where order doesn't matter at all, like just choosing a committee. Second, application. This is where practical application turns into a real professional skill. Can you use the appropriate terminology and correct formats to represent those scenarios? And third, and honestly most importantly, analysis. The Cambridge syllabus heavily emphasizes that top-performing students don't just memorize. They exhibit a connected, conceptual understanding that transfers to totally unfamiliar contexts. Because in the exam room, you are not going to see the exact same seating arrangement problem you saw in your textbook. If you just memorized a procedure, like Alex, you're going to freeze. If you rush the context, like Sam, you'll end up applying a combination when you desperately needed a permutation. You have to systematically transfer your core principles. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's jump back into the framework. How do we actually structure this conceptual understanding onto the page? We're going to adapt a classic analytical tool, the Peel framework. And trust me, it maps perfectly to the standardized sequence you need for solving permutations and combinations. Step 1 is the point. Identify the key elements. For example, if you're choosing a committee of 5 from 10 people, your point is identifying that order does not matter. Step 2 is evidence. Apply the relevant theoretical principles. Since order doesn't matter, you need the combinations formula, not permutations. Step 3 is explanation. Execute the analysis with crystal clear working. Actually write out 10 choose 5 and show the factorial expansion. Step 4 is link. Verify the results and present them clearly, double-checking if there were any hidden restrictions you might have missed. This standardized sequence, that is your script. Following these 4 steps demonstrates exactly the higher-order assessment objectives that examiners crave.
Let's head into Section 3, the rewrite.
Now for the transformation stage. We are going to take those flawed scenes from our earlier directors, Alex and Sam, and fix them live using our new Peel framework. I want you to mentally accept this 60-second rewrite challenge with me. Think back to Alex, who overloaded their answer with raw facts. To transform those red pen marks into green check marks, Alex needs to elevate that answer from just a descriptive level to an analytical one. Instead of listing every formula under the sun, Alex needs to use step 1 of Peel. Identify the specific key elements from the unfamiliar context. Is it an arrangement in a circle? Are certain items kept together? Now think of Sam, who just rushed and gave a final answer with 0 working. Sam needs to focus hard on step 3 of Peel. Execute analysis with clear working. The presentation of mathematical information follows strict conventions. By forcing these flawed answers through the Peel filter, we strip away all the nonsense filler and highlight the actual mathematical action. This right here is the ultimate mathematics success blueprint. Stop scrolling, subscribe to our YouTube channel Ace the Exams at acetheexams_IGC to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGC and turn on all notifications so you never miss our weekly exam strategy sessions. All right, moving to Section 4, Interactive Workshop. Now that you have the blueprint, let's actually put it into practice. In Probability and Statistics 1, your data interpretation skills are absolutely crucial. You're regularly required to extract data from texts, interpret complex relationships, and draw evidence-based conclusions. So imagine a 60-second timer counting down right now in your head. You are faced with a complex scenario involving selection criteria and arrangement limitations. You have to systematically process this sequence. Identify the elements, apply the principles. Are certain items restricted just to the ends of the arrangement? Are identical items causing you to overcount? This is exactly how you handle the pressure test of a completely unfamiliar context. Knowing exactly where students usually trip up during that pressure test is a game changer. The principal examiner reports are literally the ultimate cheat code. So here are the top 3 examiner warnings that consistently cause students to bleed marks in permutations and combinations. Warning 1. Examiners report that students repeatedly confuse cause and effect. They mix up the conditions that dictate whether an arrangement is restricted or unrestricted. Warning 2. Students forget to check format and presentation. They totally ignore the strict conventions, like properly denoting permutations versus combinations in their actual working. And warning 3. Answers are not specific to the context given. They provide a generic, memorized answer instead of an analytical one tailored to the specific limitations of the scenario in front of them. Let's test this right now. Imagine reading a student's paragraph detailing a probability scenario, but somewhere in there, they've confused the cause and effect, falling right into examiner warning number 1. Can you spot it? Are they assuming an alternative interpretation without actually evaluating its effect on the conclusion? Are they applying a combination when the context, say assigning specific roles like president and vice president, clearly dictates a permutation because order matters? Actively identifying these flaws in practice builds your muscle memory for the real exam. You absolutely must evaluate the evidence quality by identifying limitations. And finally, Section 5, the top mark system. We are in the final act now. This framework of higher-order assessment objectives perfectly maps out your journey. Just notice the progression here. Down at the bottom, we have the descriptive level. This is exactly where Alex was stuck, just stating facts and formulas going nowhere. In the middle, we have the analytical level. This is where you actually apply the combination or permutation formula to the problem. But to reach the very top, to secure those final differentiating marks, you must reach the evaluative level.
Evaluation in permutations and combinations means identifying limitations, clearly stating any assumptions you've made about the groupings, considering alternative interpretations, and most importantly, evaluating their effect on your final calculations.
Which brings us to a massive examiner alert. Students lose marks by not showing working. Even if your final answer is dead wrong, method marks can absolutely save you. This is the famous method mark strategy. Remember our friend Sam, who just rushed to the final number? Well, if Sam's final number is wrong, Sam gets a 0. But if you apply this systematic processing sequence, if you execute analysis with clear working, showing your factorials and your logical steps, you are capturing marks every single step of the way. Your structured analytical process is just as vital as the final answer itself. Marks are awarded for the process. Do not leave money on the table. Show your working.
To summarize our production masterclass today, here is the complete mathematics answering system that guarantees maximum mark retention. Just stick to these 3 rules. Rule 1, command word decoding. Target those distinct cognitive domains. Know exactly whether the question is asking for an arrangement or a selection. Rule 2, Peel framework application. Use point, evidence, explanation, and link to systematically process the data, handle restrictions, and present with strict conventions. And Rule 3, time management matrix. Don't rush like Sam, and don't overwrite like Alex. Pace your scene perfectly.
Now you might be wondering, why go through all this effort to structure your answers like a film director? Because the data doesn't lie. Students who consistently implement these specific mathematical strategies, who focus on the methodology and the higher order evaluative levels in permutations and combinations, see an average improvement of 2 grade boundaries. 2 entire grade boundaries. But that only happens if you practice consistently and actually apply the systematic processing to your past papers.
Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
We also want to hear from you. Drop a comment below with your target grade for mathematics and the biggest challenge you're currently facing, especially if it's within permutations and combinations. Our team literally responds to every single comment. Like and share this explainer with a study partner. Ace the Exams. Your Cambridge success starts here.
I'm going to leave you with this one final thought as the credits roll today. Think about the method mark strategy and that standardized sequence we just discussed. What is the very first step you will take today to secure those vital method marks in your next permutations question? Are you going to start identifying key elements better? Are you going to clearly differentiate when order actually matters? Make that commitment to yourself right now, dive into a past paper, and start directing your masterpiece. See you in the next session.